Stu, and today I'm going to speak to you on an introduction to reverse engineering or reversing. And I'm going to go over with you about how to take software apart. This is going to be, I've simplified it, I believe, as much as I can so that anybody could understand this. And it's not going to be anything difficult. There's 3 apps that I'm going to take apart during this. And this can apply to hardware as well. So here's my disclaimer and disclosure. This is for educational purposes only. And I assume no responsibility if you use this presentation in an unlawful manner. My disclosure is just that this was prepared by me in my personal capacity, and views and opinions are those of me and do not reflect my employer. So, overview. I'm going to go over my background, and then we're going to hit some terminology in reverse engineering, as well as go over some things about static and dynamic analysis. And then we're going to hit some application puzzles from hackthisSite.org. And then we'll go over some links, as well as reverse engineering tools. So my background. At one time I did vulnerability assessments with some penetration testing and a little bit of coding as well. It was more bash script coding and PowerShell. Now I started in the 80s learning basic beginner's all-purpose symbolic instruction code. And I worked on, back then, Apple IIe's, Radio Shack TRS-80s, the Texas Instruments TI computer, as well as Commodore 64. Just to give you a little bit of a background, Apple, for basic, you would do home, HOME, for clearing the screen. Radio Shack, you would do CLS to clear the screen. Texas Instruments, you would do call clear to clear the screen. Commodore 64, I believe you would do a print statement of some sort to clear the screen. So it was all kind of different basic code back then for each system. I have tutored a little bit in assembly and C++, as well as a couple other languages. Now, for me, assembly language is just always interested me, and I have a book on it, Assembly Language Step by Step, by Jeff Duntman. I'm a friend of his now, and that book is fabulous if you want to learn assembly language, because it just simplifies it. It's an old book published around 2000, but it is a good book to use to learn assembly language. Now, software reversing requirements. I have done reading and some research, and this is basically, to me, what the software reversing requirements are. Having a software development knowledge. This is good so that you understand, the different phases of doing software development, including compilation. And then having an assembly language and C language knowledge. To me, C language is the closest I feel that you come to assembly language without getting into assembly language. C language allows you to do bit manipulation, and like I say, it comes the closest to assembly language of all the high-level languages in my view. And then the patience, curiosity, and a passion to learn. You need patience for this because even though you have software development, software forward engineering, basically, you still need the patience to debug your code. With this, it's different. It's an assembly language, and you have to have the patience to actually look through the code, because it's, again, not plain English. and a curiosity. How do things work? That is basically what you're looking at in software reversing or in any kind of reversing. How do things work? And again, passion to learn it wraps it all up, because it's one of those things of, if you have the passion to learn it, then you're going to have the patience and the curiosity to learn it as well. Now, reasons for reversing. Give an input and output. How does it work? Right? So you have also software cracking. Now, this is illegal. They had, I don't know if it still exists, they had a thing called Juarez Crack. So it was a website out there that would give you serial numbers that you could use to activate applications without paying for them. Basically illegal. So then you have another reason for reversing is software and hardware manipulation. Software manipulation is what I'm going to get a little bit into on this brief. Hardware manipulation, the closest thing I can really tell you about that I can relate to is way back when I decided I wanted to build myself a guitar amplifier, because I've played guitar for a number of years, and I didn't have money for an amplifier, so I decided I'd build one out of 2 stereos. And I did a little bit of soldering and, just basically rewiring some things. And I figured out how to wire one stereo as my clean and distorted to another stereo, which was my main amplifier. And then you have how to recreate software. This is the one that I'm going to focus on quite a bit during this brief. Now, small bit on legalities of reversing. So, Secrets of Reverse Engineering, published in 2005. There is legal debate about it. And if you really think about it, when you sign a disclaimer, you're installing stating you won't reverse engineer the software. And again, as Secrets points out, you want to seek legal counsel always when it comes to getting involved in something that is high risk reverse engineering. Otherwise, could go to jail. So, what is reversing like? There's an art and a science to it. To start, static analysis is long hours, like I said before. I've spent many hours just doing practice applications, and when you're doing this, and I'll show you one in a what they call a debugger. It's software to take the application kind of apart, and you end up spending long hours, and you're taking notes, and you're going, okay, this happens here. Then what do I see? What am I seeing? And you're taking notes to yourself and saying, okay, at this location I saw this, etc. So, and then when you're doing that, you also have to know what to do and when to do it, like setting breakpoints. And I will show you an example of a couple of breakpoints I did in an application so that you see what they look like. And then stepping in execution versus executing to the end. Some apps, like I say, spending long hours. I've spent long hours stepping in execution on practice applications and going, what's going on, and again, watching things as I'm stepping through, and it can take a long time. And then executing to the end. There are times when you want to execute to the end just to see what's going on with it when you get to the end result. And then, as Matty Stone says, Matty Stone is from, I believe it's Project Zero at Google. And I took an Android reverse engineering course from her back in 2020. And Android is different as far as reverse engineering is concerned compared to x86, what I'm going to show you today. This is paraphrasing, but basically when you go about performing it professionally, chances are you're going to be doing malware analysis when it comes to reverse engineering. And you need to find out, what is this doing? Malware, ransomware, what exactly is it doing? And you want to do it fast because you have a client that is going, okay, I was working on that and now I'm not, and I have information on there and I want to get my work done. So what's happening? Am I going to be able to get to my information, etc.? So it can be a high pressure situation when you're talking about doing malware analysis. Then static analysis. You have static analysis with, and Ghidra and x64DBG are two examples. There are others. And what you're doing in static analysis is, one, you're identifying where the original enter point or OEP is, so that you know where to start your static analysis. Then you're trying to identify key strings. Sorry, congratulations, password is, and other key strings out there. And the reason you're identifying these key strings is it can give you clues into what is going on in the application, and where it can even maybe give you an area to look at for other code that would point things out to you. Then you have identifying even key the program structures, like looping. It's looping. So what is it exactly is it doing? And I'm going to show you a program with looping in it. And then you're locating conditional jumps, because if a jump's taken, what is it doing when it does do that jump? Where is it jumping to? Is it exiting the program? I don't want it to do that, maybe. So how do I avoid the jump? I'm locating a compare. I will show you an application with a compare statement, or even test statements. But with a compare, it's like an if-then statement in any of your higher level languages. If the password is equal to this, then, print whatever. So this is some of the stuff that you look at in static analysis. Now with dynamic analysis, you're usually executing the application in a virtual machine for safe space. And then you do things such as monitor the registry for changes in Windows to see whether or not is maybe the malware going to execute again, or a virus going to execute again once you boot up the system, reboot the system. Monitor with a network tool like TCP dump or Wireshark. I'll show you an example with Wireshark just to see, where is it going out to the network? What is it doing? And then observe what happens on the screen. Does it give you a skull and crossbones, when you execute the application saying basically you're screwed, I own your system type of thing. And I do mention, does it go blank after data entry? I'll show you an application that was going blank, whether I entered the right password or the wrong password, and I had to pause it in a debugger called OllyDebug, and I'll show you a little bit of that later on in this presentation. And then monitor for file creation or manipulation. This is something that Paul Chien on Udemy, he had a course that I was taking, and it was looking at file creation. So now we go on to the simple application. App 1. From hackthisite.org, thank you. From hackthisite.org. So when I do this application, I'm entering a serial number, 1, 2, 3, 4, and I hit authenticate, and it says sorry, right? Now, when you're looking at these applications, take note of what you're seeing, like authenticate your software. What are you entering? And then, sorry, you entered an incorrect serial number. Take note of some of the stuff that you're seeing here, because when you go to reverse engineer it, you may see, like I say, some of these strings and so forth and go, oh, what's around it? So it'll give you some hints, but again, what's around it? So it'll give you some hints. But again, authenticate your software. Sorry, you might even see congratulations. So here's the solution process for app 1. You're ending up running a strings command in Linux. And for those of you that don't know about Linux, that's one of the reasons I'm explaining it to you. So the strings command in Linux command line. I'm doing a strings on the executable, which is the app that I'm looking at, the app that I'm reversing, and I'm doing app1 win.exe, and then I'm going ahead and I'm going to push it into or append it to app1.txt. I do this because it's easier for me to look at it in an editor than it is for me to look at it on command line. So, but the purpose of the strings command, all I'm doing is looking to see the text inside that binary file, that .exe file. That's all I'm doing. So if you look over here on the right side where I have app1.txt in gedit on Linux, the screenshot here, you see authenticate your software about the middle of the screen. And then you see 01301414, etc. I bet that that's the serial number that we're looking for. Okay, but me being the speller person that I am, I looked and I saw congratulations and I went, I don't like that. So I'm going to say the proper word is congratulations, and I'll show you. So then first thing I want to do is fix the congratulations. And yes, it can be fixed. I use a hex editor. I believe I use HXD. We'll take a look at that. Anyway, I do a control F to find the contrat, and then I change the value of T to a G, or it's going to be 66 in hexadecimal because that represents the little letter G in hexadecimal. And that's what the computer needs to see. And you'll see it once you enter the number. If you're interested in how the hex editor technology works, I highly encourage you to read make use of .com. Then what you're going to do is this is very important, by the way, very, very important. You're going to save this as a different file, because if you save it as the original file, then if they need to do investigation on it, forensics or whatever, they want that original file so that they can have that original evidence. If you've manipulated it and then written it over it, then they don't have the original evidence. So save it as a different file so that you can have it for later on if needed. So then here's everything basically fixed. So I go from 74 to 66, again, the T to the G. And then I enter the serial number over here on the right-hand side, and it says congratulations. So then that is app 1. And it is fixed, and we found the serial number. Now, remember what I said about software recreation. Again, you can use reversing to study, software, how it works, etc. So why not recreate it? Now, what I'm going to show you next is C code, but it's not this application in its entirety. So this is a basic application in C code. It would be run in DOS mode. You wouldn't have any nice GUI or anything like that. So for those of you that don't know C code, include first line stdio.h. This is just a standard input-output library in C, is all it is. Then you have your integer input equals 1223. This is just, I said I'm going to do 1223 is the code that the user needs to input. Then the integer main is the main part of the C program. Then you have the integer for the serial number. And all that is just the variable for the user input. Printf, this is just going to print on the screen. Please enter the serial number for the software. Then you have the scanf. The scanf is an input statement in C code, which says %d mean. F is an input statement in C code, which says %d meaning digit, and then at serial meaning the variable, and you're going to, this is the user's input for the serial number. Then you have an if statement of serial number is not equal to, that's exclamation equals, not equal to the input. If it doesn't equal to 1223, then print, sorry, wrong serial number. Otherwise, print congrats, password to this level, and whatever the password is. And then return 0 in C is just basically saying, hey, everything worked out well, everything's good. And that is a basic application in C code of App 1 recreated somewhat in form. Now, App 2. Again, thank you, hackthisite.org. We're observing the status connecting. So this is probably a web connection, network connection, network connection, right? So I'm going to go ahead and do the simplified, use the Wireshark tool so that we can see what we need to do next. So then we're going into Wireshark, and we see 192.168.1.2.0, the squared entry there in Wireshark. And then the 192.168 is myself, 137.74, that's hack this site. And we're doing a get, which is basically the web browser. This would be like similar to a web browser going out and retrieving what it is that you want to pull back, that your computer's looking to pull back. And it's going to application, app 2, and it's going to application, app 2, keys 123.txt. That's what it's doing. So then if we go to the next slide here, we see if we go into a browser and we type in all of this up top, www.hackthisite.org, missions, application, app 2, keys 123.txt, we will see all these serial numbers dump. And so there you go. This is where it's going to. So then the solution, and you should be able to take any of these serial numbers and put it in. I just decided 45910. So I take all of this in and I get congratulations. Right? So that's app 2 finished. Now, here are some thoughts. Again, how do you pull the serial numbers from the web page and display it? I don't even want to have to go to that web page. I don't want to have to use Wireshark. I don't want to have to do any of that. How did you recreate the application so that so it goes to the web page and says, here you go. Here's any of the serial numbers that you can display or that you can use, on the display. So it's just another way of doing things. Now this one is a little bit more advanced. Again, thank you, hackthisite.org. This is app 5. And this app disappeared. Whether it was the wrong password or the right password, it disappeared. And what had happened is that I was going through these apps before another presentation and to refresh my memory on it. And then I looked at app 5 and I went, oh, it doesn't matter what password I enter. It's still disappearing. What's going on? That's why and this is the one where I said the screen goes blank, whether the password is entered wrong or right. This is that app. And basically, it's briefly displayed, right? But if you pause it in debug or similar tool, you see it's invalid password. I enter ABCD and it says invalid password. So that's where we're at, is invalid password right now. Now for the solving process. Now Wireshark provided nothing. Strings command displayed. The password is %s, which is basically nothing. That's %s is for string representation in C. But I went, well, I can use the password %S maybe to search to see if there's anything out there, like a compare statement or password, that the actual password or something. And then I came across this, compare ECX double word pointer. It's D word pointer, but double word pointer. And then so the SS is basically looking at the stack. For reference, all the stack is it's a temporary storage location. For this purpose, that's all you need to know, is it's just a temporary storage location. And then the colon EBP plus EAX times 4 minus 24, just consider that the formula, and we'll get into it here in a minute. So I'm breaking this down a little bit more. Now, here are your basic definitions for ECX, EBP, and EAX. These are very basic. Okay? But the bottom line for this brief, so that we keep this very as simplified as I can think of making it, think of the ECX, EBP, and EAX as variables. That's all they are. It's just variables. Variables that hold values. So that's all they are in this case. So now I put this slide in here for a reason, because we're going to get a little bit into auto debug. Some people freak out a little bit when they see it because it's not plain English. I'll just put it that way. So the first slide, you want to just think of it as line numbers. They are memory locations, and they're not separated by a quantity of 1, but don't worry about it. They're just line numbers is all they are, just line numbers. And then the next slide will have those line numbers in the first column, and then alphabetical and numeric instructions in the middle column. And then further on, we'll see the assembly language instructions. Move is one, CMP, compare is another. There's push, pop, and others. That's going to be in the third column. And then any ASCII, which is American Standard Code, which is basically anything English, is going to be in the last column. And I'm going to show this all to you. And then the IP is the instruction pointer, which points to the current instruction. That's for the CPU so it knows where it's going as far as the instructions are concerned. So that's all this is. So your first slide here, again, just line number 1, line number 2, line number 3, etc. If I just didn't fill it out the rest of the way. And then you have hex instruction, C 745 space, D4 space, and then all the rest of it are zeros. Those are 2 examples of hex instructions, and it goes down the line as well. So again, line numbers and hex instructions. That's all it is. Then I've added assembly instructions. So now you have your line numbers, you have your hex code instruction, and then you have your assembly instruction, like move, D word, point, PTR, SS, and the rest of it. Right? That's all that is, though, is assembly instructions. And essentially what assembly instructions is so that you don't have to look at the C745 space D4 space, all those zeros, and go, oh, that's move, D word, PTR, etc. It just makes it much easier for the reverser. And then I'm showing you the ASCII characters. And again, it's just plain English is what it is. And it allows you to go, oh, this might be where the password is stored, or whatever the case might be. It's supposed to make it so that it's easier for the reverser to look at and go, okay, I have ASCII characters here. Now I can look around here for, possibly another hint. Okay. So we're now onto the current instruction, the instruction pointer for the CPU. As you can see, the red arrow pointing there to the instruction pointer. Now, And again, this is the same screen with the line numbers, hex code, assembly instructions, and ASCII, or plain English representation. I'm just showing you the instruction pointer. Now, this instruction pointer I want to show you is pointing to a red dot here. This red dot, and there's another one below that. You have the gray dot, and then the next red dot below it. So these red dots are breakpoints. I set this breakpoint at where this instruction pointer is because this is our current instruction that I'm going over right now. So that's all that is a breakpoint. The other one I set for something else, and I'm not exactly sure. But anyway, this is the breakpoint that we are at where the instruction pointer is at. Now, the debugger will actually do the math for you. However, I encourage you to learn how to do hexadecimal math. And I was looking out there for a instruction on how to do hexadecimal math that was very dumbed down. And I haven't found one. I've looked on YouTube and I've done some searches, and I haven't really found one that meets what I feel is easy. Anyway, with this one, I'm looking at ECX. And the ECX, again, it's a variable. Remember that. It's just a variable. And it contains what was entered. ABCD and hexadecimal. Now, this has with 61 is equal to the letter A and 64 is equal to the letter D. Okay? However, if you go down into the little gray area in this box, you'll see ECX equals 64, 63, 62, 61. Which is, oh, that's backwards compared to what you're showing. Yes, it is. This is just a reference point for you. I'll tell you, this is big endian with an E versus little endian with an E. You can look into it, but it's just a reference for right now. That's all that is. Now, if you go down to the next line, you're going to see POWE, A, B, C, D, new line. Okay, the POWE, as I say up here in the second line, says stack has POWE, 65 equals letter E, add a line number, and then the CPU is comparing only the first four letters, right? So it's only comparing the POWE to the ABCD that we entered. Now, I said 65 is the letter E. Now you'll see 65, 77, 6F, 70. Again, that's POWE spelled backwards. Again, little Indian versus big Indian. So that's what we're looking at right now. Now, with this, we're looking at the actual stack. Again, think of the far left as just line numbers for right now. It's fine. POWE location, though, is down here where I'm pointing the 65, 77, 6F, 70. Now there is a loop that I'll show you here in a little bit in the code that compares the letters 4 at a time again, POWE to ABCD, etc. It will compare those letters as long as they're good to the power tripping up to the 0A67. And then as long as it's power tripping, good job or whatever the congratulations is. But power tripping is the password for the app. But again, this is the stack. It's a temporary storage location, and all it's doing is it's looking at the stack 4 letters at a time in each location until it. And the other thing is that again, it's only looking at 4 at a time. So therefore, since the ABCD and the POWE don't even compare because they're not equal, it will immediately say invalid password. It won't even continue on to the rest of them. So I talked about the loop in the previous slide to gather the next 4 characters. Here's the loop, big red arrow. So there's the loop that I was showing you. Now, the end state here, again, it will disappear whether you enter the right password or the wrong password. But it's going to display, if you pause it in all a debugger, another debugger, it will say password is power tripping. So that one, it's as long as you enter power tripping, it's good. So then, again, another thought. How can you make that app stay on for the display to stay on so that the user can actually read it and go, oh, I got the right password. And then, how could you grab the password? You don't even have to look in the stack for the password. It just says, hey, hint, enter power tripping, right? So you don't even have to look for it. Now, that's the end of the apps. We're looking at self-education and reversing. Now, CTFs. I did CTFs some time ago, and I'm just over them. But the thing is, to me, those and the CrackMe applications, they're very limited as far as education. If I were to host a CTF, which I most likely wouldn't, I would say, okay, here's the CTF, but here's the thing. Yeah, you'll have different levels, but I want to see how many ways you can get this flag. Not just one, but a few ways to capture the flag, because the more tools you have in your toolbox, the better off you are anyway. And then you have books like, again, Secrets of Reverse Engineering, and then there's Malware Analysis with the Alien on it, and there's a guy out there, I believe it's called Sam's Class Info, if you look it up with search engine. He does this for a community college, and he does a very good job, in my opinion, of going through the book. And then you have Udemy. That one, your mileage can vary with Udemy. I'm not going to deny it. I've had some bad courses on there. But I did Paul Chin for malware analysis, and there's a couple others, but I was doing his. My only thing with Paul was good instructor and all that, but he's using apps, which I know everybody does, to, do the malware analysis and everything. And I'm fine with that, except we inherently trust these apps for what they give us. We don't really check them, per se, to see whether or not the answer is correct, right? And I tell people, I say, if you know, going back to what we were doing with these apps, if you know how those applications, those tools work, and you created your own, you would, learn how to create that similar application, and you would learn how it works on the inside. Oh, and by the way, it would be yours. So therefore, you could look at the code and go, if something on it for whatever reason broke, you could look at the code and go, oh, because this is your code, and you can go ahead and, update it or whatever you need to do. Then you have YouTube videos. There's a ton of them out there, but this one stuck out to me. Reverse Engineering and Weaponizing XP Solitaire. XP Solitaire is an old program. This gentleman does about 3 hours worth of showing you how to do this. And I didn't think I was going to get into it, and I actually did the whole 3 hours. And it's very interesting. One of the examples that he does is he shows you how to make it so that the countdown timer has no effect on decreasing your score. And he uses the decompiler in Ghidra, and he just shows you some of the things. I thought the video was pretty amazing. Then you got beginners.re. This is a PDF written by a Russian on how he learned. This one requires a donation, or he would like a donation, I think is what it comes down to. But anyway, this is over 1,000 pages on how he learned it. I haven't gone through the whole book, but if I remember right, he uses the Hello World application, and he's using Linux in GDB, which is a GNU debugger. It's a different kind of debugger and command line for Linux on Unix command line. And he is just going through that with GDB, and it's a pretty, from what I'm seeing, it seems like a pretty good read. And then OpenSecurityTraining.info. This has videos with Frank Paz of MITRE. At least I think he's still with MITRE. Anyway, he displays some of the assembly code instructions, like the loop structures. And he goes through with this bomb.exe file, and he's labeling and showing his students how he's going through this. Because the thing is, you label it, and you know what it's doing. Then you're only left with what you don't know, type of thing. And when it comes to reversing, you just need to practice. I mean, practice, 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 practice. That's what it boils down to in a nutshell. Because the more you practice it, because with this stuff, in my view, if you don't practice it, you really do forget, kind of what you were doing. And then you have your tools for reversing. You have the virtual machine again for the safe space for executing. Then you have Ghidra, among others, for debugging, decompiling. Now, with IDA Pro, I checked it a while back, but the free version has flowcharting in it. Flowcharting can make your life so much easier because you just follow, I entered it here, okay, it's going to take this direction, whatever, and it's just much easier to follow. And it has the code in there, so you're so you are following the code, but it gets you there quicker. Hex editor, I showed you a little bit on that. Network monitoring tools, I showed you a little bit on that, on the IP addresses. And then sysinternal suite. This was by Mark Rasunovich. And I believe he has a team behind him. He has process monitoring, process explorer, which are process explorer, I believe, is the one that is like Task Manager, but it's much more in-depth than Task Manager, and he's done a good job with that stuff. You also have a listing found here for malware analysis tools. And then, again, knowledge. Because you're going to get the stuff that I showed you isn't really going to, it's not going to exist out there to my knowledge. And it's going to just be more complex. And I've come across a practice app that had a debugger detection. In fact, it said, is debugger detected? And you have to, I'll just say, do something in order to fool the application into, no, the debugger isn't detected, continue on. And then there's, like I say, there's the books mentioned before, and then there's the articles, because again, it's just more tools. Okay, so that is it. And another topic that I think deserves bringing up is how device drivers, how are they created or even modified? And for those of you who don't understand that, say you have USB or even a DVD or CD-ROM or whatever, it's how the CPU and that device talk to each other. It's basically it's that driver. And then I'm available to talk on the subject, because if you keep secrets, nobody really learns. And the one thing I want to point out too is that in what I call the information security community, I have come across some large egos. I consider myself a very humble person, or I try to be a very humble person. And I tell people, if I can help you out in any way possible, I will. I will absolutely help you so that I can turn that light on.